Welcome back after lunch, everyone. We will be joined very shortly by Abbey, who's chairing our first session, and then I'm going to use this opportunity to make sure that everyone who's giving a short paper now or a lightning talk is down in the front row in the seats reserved for speakers, so that your wonderful chairs don't have to worry that you're there and that you're ready to go. And still waiting on Abbey. I'm going to sit, and hopefully Abbey will be here in a second. Hooray!
Okay, thank you. It was a great poster session. That's where I came from. Do we have a slide with the next? Yes, okay, here we are. We have 4 talks. One of them is going to be a video talk, the second one, I believe, yeah. And I would ask the presenters to introduce themselves as they come up. And we'll get started. Thanks, come on, Christopher.
Thank you very much. Very happy to be here. So my talk, the title of my talk was Errare Machina Est, and the idea is to present you a very large project that we are conducting in France about the French census. And the idea is to collect all the nominative list of the French census. You have an example here in France from 1836 to 1936. And to automatically transcribe them, organize them, extract the nominal information, and to build a very large database with this population information. And the partners of this project are Teclia. I'm Christopher Kermorvant from Teclia, the founder. We are a company specialized in document processing, but also the National Network of Archive, France Archive, the National Institute of Demography, INED, and the Paris School of Economics. So the objective of this project is really to produce a database for scientific research in demography, history, and economy. So how we did that, very briefly, we collected around 20 million images of this census. We organized them into our platform, ArcIndex, which is an open source platform that you can use to process documents at large scale. And it's based on IIIF, so we also have made these images available in IIIF, and we have ingested metadata from the services, the archive services. And in fact, that was really the point that took us most of our time. It was not really producing the result with machine learning, but it was interacting with people in the archive. Because we needed metadata and we needed to organize the data in the platform. So once we have the data and the images, it looks like this. You have all the documents organized by services, year, municipalities, and you have metadata associated to it. So now the processing, we use the model that is able to process the image as a full page. So we have only one model. There is no line detection, no column detection, no entity recognition. It's only a single model that takes the full page and produces the kind of Excel sheet with the information that you want. So we have the extraction of the name, surname, occupation, age, linked to the head of household, and the prediction of the households. And why we did that is also that really the objective of the project is to process at large scale. So we didn't really aim at improving the quality of the model as much as we could, but we wanted to process a first batch of everything. And so if you have only one model, it's a lot easier to process at large scale because you don't have to rerun the model if you have failures. You have only one point of failure of the full process. And as I forgot to mention that all the software is open source, both the platform for processing, the software for recognizing the document. So now, what about the target of my talk? We wanted to have a look to the errors and what is the impact of the errors on the downstream processing. So, for example, if we focus on first names, the error rate is 13%. So, what does it mean, 30% of such a large corpus? So if we look at just 80 million mentioned, 80 million entries in the database, we have almost 1.8 million different first names values. So it's a lot of values. You could say, oh, it's not possible to have so many different first names. And in fact, if you look at how many first name appears only once, it's 1.5 million. So it means almost 1.5 million are either very rare first name or errors. And if you take the most frequent first name, it's Marie. Almost 10% of the population in France are called Marie at this time. So if you don't know someone, you just call her Marie, and you're almost good to go. If you take the top 10s, then top 10 name, you already have a coverage of 32%. If you take the top 100 first name, you're almost at 70%. So it means that, 99.999% of the first name are very unfrequent. So it also means that you don't really need to have a correction of all this diversity of first names. But you could do that. So we wanted to know how many first names do we need as a list to have almost 99% coverage. And we find that with 25,000 first names, we cover almost 97.98% of the first names. So the idea here is to say that, okay, we could correct them. We could correct the first name to have a coverage of 98%, but is it really useful to correct these errors? So what is the impact of the errors? So you have errors that have for which there is a large error rate if you compute the character error rate. For example, if the annotation is cultivateur and you have CTV, which is an abbreviation, obviously the error rate is large, but there is no impact because it means the same thing. And same if you have a change in the order, cultivateur propriétaire or propriétaire cultivateur, this is the same meaning. So it's not really a problem, but the error rate is very large. On the other side, you have small differences that matter. For example, Abancourt and Abocourt. It's exactly the same name, but the difference is 202 kilometers. So you have only one character error rate, but a large distance between the two. Same for Poncet and Poncet. Also, for example, on dates, there is a large impact, but we had a good surprise with the model because it's very good on dates. So that's a point that is really reliable for further studies. And also, if you want to study the gender, you want to study gender on the population, on the occupation. It's very important. And usually, gender is the marker of gender is relies only on one or two letters. For example, Julien is masculine, and Julie is feminine. Louis and Louise, it's a gender difference, but only with one letter. Okay, now. As you know, when you use large language models, in this case, it's not a large language model, but it's a generative model that we use for the recognition. So there is a generation of text. And as you know, the model can hallucinate. So in some cases, this is very easy. If you have a transcription like this, it's very easy to detect that this is an hallucination. But sometimes you look at a specific household, and I didn't have to look very far to find one. I think it's the third example I looked for when preparing my presentation. And I looked to a household with everyone almost is called Jean in this household. But that's true, the father is called Jean, the son is called Jean, and the sister of the son is called Jeanne, so it's exactly the same name. And they're all born in Saint-Jean, so it's incredible. But so if you look at the prediction, you have 5 Jean in the same household, so it's not possible to have all these Jean. But it's true, and it's not unusual. So you can have mistakes in the source. It's possible to have duplicate lines because it was written by someone who had to copy millions of lines, and so not millions but thousands of lines. So you can have errors in the original. You can have errors also when the document was scanned, so you have duplicate pages. Obviously, it's a problem because if you have a small municipalities and you have twice the same page, then you may double the population of this city. And as I said, you have very ambiguous human behavior. We didn't know that so many people wear the same names inside the same family. About the quality control, so it's very easy to develop tests to identify where is the problem. For example, confidence score, we know that's not really reliable, but you can detect hallucination. You can count the number of lines. You can make a test on the age very easily. But you can also compare what you produce with what is known. For example, we know the population of each municipality in France because it was collected by the statistical service. And when you compare the population that we have extracted and the real population, in almost 60% of the case, this is perfect. So we have exactly the same population in the registers that we have extracted that is known by the statistical service. And if you go up to 5% error rate, you're almost at 80% of the services. You can also make a comparison with reference lists, like for first name, and you can compute aggregated data by age, gender, and compare that, what you know about this population, you can compare it to what you have extracted. So finally, what is really important is that really the quality of the document of the data depends on the usage. So for archivists, for example, they really want to understand how it works, because when there are unexplained error and you say, okay, I don't know why there is this error, they are a bit skeptical about the quality of the result. For social science researchers, they are really used to have errors in their data, so they can cope with it. And for genealogists and general public, well, they have personal stakes. They want to find their own family. So if you make a mistake on the first name of their grandmother, they're very unhappy. So this is a challenge for dissemination, because it means that you may have different databases with different level of quality. So you have to distribute that. And also one thing is that there is no final version of the data. But you can still have a look to socface.teclia.com to have the current result. And maybe an idea would be to use this kind of data to replace the CAPTCHA that maybe are disappearing. But I've created this CAPTCHA where you have to click on all the Mathilde that you can find. Maybe it's an idea to correct the remaining errors. Thank you very much.
All right, that was great. We're going, not video, but hybrid. So thank you to the British Library AV team for making this happen, Cloudflare for keeping Zoom online for 10 minutes, and Abbey for starting the clock now. So good afternoon, everyone. My name's Snydman from Harvard. I'm here with my colleagues online, Angela Kilsdonk and Amy Deschenes, to talk to you a little bit about our work on Collections Explorer, which is an AI-driven, user-centered library discovery environment currently in development. So our collective challenge, there we go. Well, it's going to work. Our collective challenge as information and academic organizations is to match users, researchers, students with the information they need to be successful in their work. And to do that in an environment of vast and dispersed and growing information complexity. And to also do it in a way that's fast and easy and sophisticated. So, and users have been clear that we need to do better. With notable exceptions that have been kind of seen this week, a few notable exceptions, current discovery systems aren't doing the job. They can be overwhelming, inconsistent, unintuitive, and especially when it comes to our special collections. These materials are often trapped in multiple bespoke systems using different metadata standards, and in many cases, they're just too hard to find. So we're here because we believe AI can help us fundamentally transform this experience, moving beyond the now aging paradigm of keyword search towards natural language interfaces, contextual answers, and discovery tools that help users go deeper into our collections, make unexpected connections, and ultimately find what we need. So Collections Explorer is our first major step at Harvard, an initiative we're calling Reimagining Discovery. And while we look at this as a long-term transformation, we chose to take our first swing at our special collections discovery environments because they're some of the most unique materials we have and often the hardest to find. So with that, I want to hand it over to Angela to show you what we've done so far.
Thanks, Stu. So I'm going to do just a really brief demo of Collections Explorer, and then I'll talk a bit about the technical foundations of the system. So this is our homepage, and I'm going to enter a natural language query about items in the collection that are hand-drawn or painted images, plants or fungi created before 1930. So here we have our search results. The search results, they contain records that are relevant to the query without relying only on the keywords. It's a pretty nice example of semantic search in action in the system. There are results in here for illustrations and drawings within that specified date range. So the system has done a pretty good job parsing out a relatively unstructured and complex query. Each of the search results does contain an AI-generated summary under About This Material that explains why it's relevant to the search query. The LLM is using the query, the record, in this case, it's a finding aid, and then our system prompts to create those summaries. You also notice many of the search results contain a note, includes digitized items. So at the top of the interface, we have some filters. We could limit our results to only those materials with digitized materials that are viewable online through that finding aid. We can also further refine results using other filters that we have in here. To start with, we have collection date, repository location, and resource type. We anticipate that will expand as we add more data sources. And then right now, for the finding aids, the title links will take you directly to the finding aid in our archival discovery system, and it'll take the user to the appropriate level in that finding aid. Here, we could look at those photos of the mushrooms if we wanted to. Going back over to Collections Explorer, just two final things to mention here. On the right-hand side of the screen, we have a feature called You Might Also Try. This feature suggests related searches. These are generated by AI as well, and they are based on the user's original query. Lastly, under Need Articles or Books, let's say I wanted to find secondary sources held by the library, I could click on Try Hollis Catalog. This feature is using an LLM to transform my original query into a keyword search, and then it runs it automatically in our library catalog like you see here. All right, so that gives you a look at the user side of the system. I'm going to talk a bit more about what's happening behind the scenes, including the hybrid search model, metadata ingest pipeline, and LLM guardrails, just a little bit about each of those. So Collections Explorer supports hybrid search. We are combining BM25 keyword search with KNN semantic search. So that BM25 side is providing deterministic results, which is really great for our identifiers, names, exact metadata fields. And then the semantic search side, is using vector similarity to capture those related meanings, synonyms, and returning results aligning conceptually, even if those search terms aren't matching. So our hybrid search approach is really helping us balance the consistency of keyword search that we traditionally expect in our library catalogs, while introducing the richer, more exploratory behavior of semantic retrieval. So under the hood, the vector search is using the approximate nearest neighbor algorithm to find matches efficiently across millions of embeddings. This approach is trading a little bit of determinism in those search results for speed and scalability. So for the libraries, this is a big shift. We are moving from more predictable, repeatable results to a system that's really prioritizing relevance and discovery. What we tend to see in the system right now is that the exact order of the search results can change slightly from run to run with the same query, but it's not major changes that we're seeing. We are currently iterating on our hybrid search strategy to really strengthen the semantic aspect of the search in Collections Explorer, as well as looking to options for cutting off more non-relevant results. So really that fine-tuning of the search strategy is going to be an iterative process as both the technology and our data sources continue to evolve. So speaking of data, the first data source we brought into Collections Explorer was EAD finding aids from ArchivesSpace, and we're now building the pipeline for special collections records from ALMA, which we're obtaining as MARC XML. So our INDRIS process is transforming that metadata from multiple systems into that unified searchable structure. To prepare the data for semantic search, Collections Explorer has a dedicated content field that brings together all of the really text-rich metadata. So for the finding aids, this included things like the biog-hist, the scope content notes, abstract. All that combined text is then chunked for embedding and indexing to power the semantic search. For our data pipeline, we are using Apache Airflow to orchestrate the data collection, validation, and transformation from those systems. Pipeline is normalizing the schemas, generating those embeddings for semantic search, and then we are using Cohere as the embedding model and Elasticsearch as our vector database. Our pipeline is also implementing vector compression methods, including better binary quantization, or BBQ, which is compressing that vector size with only minor precision loss, so we can more efficiently scale to tens of millions of records while still maintaining search quality. So the other AI features that you saw in Collections Explorer about this material, you might also try in searching the catalog. Those features are being powered by LLMs running through AWS Bedrock. We are using Mistral Small for those summaries and Claude Haiku for the other two features. We have also implemented Bedrock's LLM guardrail functionality to help ensure that the models are not generating harmful or inappropriate content. You can kind of see in this diagram, the guardrails are being applied both to the input and the output of the LLM. So for us, using AI responsibly isn't just about the technical safety, it's also about making sure that our use is aligning with library values as we implement it in our systems. So wanted to say, the LLM guardrails were are an important piece of this ecosystem. A lot of consideration went into how we implemented them. That could be another presentation. But for now, I'm going to hand things over to Amy. Thanks.
Hi, everyone. I'm Amy, and I'm going to cover our AI evaluations, usability testing insights, and show a sneak peek of what's coming next. So the first evaluation that we conducted was on the relevance of search results in Collections Explorer. So for this, staff and student interns were asked to evaluate whether each result in a list of return results via a spreadsheet was relevant to the user's query. So the team labeled each result with a score of 0 to 2. 0 was not relevant, 1 somewhat relevant, and 2 is relevant. So the goal for this relevancy evaluation was to determine which query strategy that Angela talked about performed best, and has also informed adjustments to how we're balancing the keyword and semantic search in Collections Explorer. And this is going to continue to evolve as we add new data sources in addition to the finding aids. We've also conducted evaluations on the AI summaries of the results. Those appear underneath each search result. So for this, staff evaluators were given 60 summaries with an associated user query and the result, and they assigned a summary rating from 0 to 2 for 3 different criteria: formatting, readability, accuracy, and query alignment. So from this work, that's how we determined to use the LLM Mistral Small for this feature. And we're actually building in a new feature into the UI where users can apply a thumbs up, thumbs down to give instant results level feedback that our technical team can use to continue to refine these summaries. And then most recently, we evaluated the suggested prompts that are in the You Might Also Try section. So this feature, as Angela mentioned, uses Anthropic's Claude Haiku model to generate alternative search prompts. And testing showed that these suggestions outperformed users' original search query in about half the cases. And then when I actually had students and staff do this evaluation, they identified 3 common categories of these You Might Also Try suggestions. There were some suggestions generated that were nearly identical, some that were linguistically rephrased, and then others that were meaningfully different but slightly related. And the feedback was to focus future development on this third category, ones that were slightly related but meaningfully different because they took users in interesting new paths. So in addition to these evaluations, we've collected feedback via an online survey, some staff feedback sessions, and through usability testing with local students and visiting researchers. Users really appreciated the low clutter interface and the usefulness of digitized only, and the you might also try suggestions. And I will just share a quick preview of what's coming next, the feedback feature and the grid results, and I'll pass it back to Stu.
And there were lessons learned, and we're out of time. Thank you.
Hello, thank you for having us. I'm Emmanuelle Bermès from École Nationale des Chartes PSL in Paris. And with my colleague Marion Charpier here, we wanted to introduce an initiative called the Pictoria Consortium. So Pictoria is a consortium for the development of shared practices and tools in computer vision for cultural heritage institutions in France. And it's hosted by the research infrastructure Humanum. The consortium is co-chaired by Julien Schuh at MSH Monde. He helped us build this presentation. Unfortunately, he couldn't be here today. It's also co-chaired by Anne-Violaine Sabados at CNRS and Jean-Philippe Moreau, who is somewhere in the room. So thank you to all three of them. Pictoria's endeavor is to help developing a joint community between cultural heritage institutions and research teams in digital humanities, and we're working together towards the implementation of computer vision solutions in libraries, museums, and archives in France. So here are the main areas of work of the consortium. Unfortunately, I don't really have the time to elaborate, but at least you get a glimpse of the many things we are doing within this consortium. And one of the major questions that has arisen within Pictoria is the reuse of available tools and workflows across projects which have different types of collections and different types of goals. So while many computer vision tools and models are now mature and have proved their efficiency with several use cases in the cultural heritage domain, so I can name, for instance, YOLO, SAM, Clip, Florence 2 models, or tools like Label Studio and RoboFlow. Adapting them to the very specific needs of one project often remains a challenge. And last January, we held a workshop with the Pictoria members in order to investigate what it means to find a balance between a tailor-made approach where each project would develop its own tools and protocols, and a ready-to-wear approach where models and workflows are already available but require the project to adapt. So we wanted to share with you some of the questions that were raised during this workshop. So we had a basic workflow modeling, and then we start asking ourselves questions like, how do we identify the use cases? Are the use cases the same from one institution to the other? Do they align with the AI tasks? Then when we are preparing the ground truth for the training, what are the rules, the ontologies, where the human resource come from, how to select the model, fine-tune, if needed, the model, how to evaluate, test the results, what metrics can we build to see if the project is satisfactory. And then once we evaluate the project and we are ready to go into production, we have questions like, is the data confidential or personal? What is the environmental impact? And finally, a lot of questions regarding the implementation phase, like, is the data really available? Do we have the skills to make that function? What is the infrastructure, the time, the data flows, the formats? And how do we ensure long-term preservation of all that? So these were the questions we were trying to address, and we are going to walk you through one example of a project to show how we tried to address them.
So the project is Tornatch with the goal to reverse the The process, sorry. So the Tornache was born in the Musée des Arts Décoratifs, and more specifically in the department of drawings, photography, and wallpaper. And there is a massive collection that is barely inventoried. And we make some stats, and it appears that if we want to do it in a traditional way, it will take 643 years. So the idea was, okay, we can do this with less time. So the idea of the project was to shifting from a century-old manual inventory to a hierarchical and collaborative AI-based approach. So I'm not going to present all the projects because Emmanuelle already did it at the last edition of Fantastic Future. So if you want to take a look, you have the QR code to the presentation, or you can follow the tiny URL on the slide. But you need some context. So 3 goals of the project are integrating AI into museum, tourism, conservation, and analysis process in the goal to developing annotated processing workflow that adaptates to the heritage context, and enriching collection with the production of metadata to improve accessibility and the discoverability of the collection. And for that, we start a project using the LC Labs AI planning framework to understand, experiment, and implement AI in the museum. So the first step is to understand. That means identifying how AI can impact the museum process. So I conduct interviews a year ago now, and 3 key impacts emerged. The first one was to optimizing collection management and documentation, increasing accessibility for researchers and staff museum, and also the general public. And the last one was enriching an immersive experience for visitors. So we focus only on the 2 first points, and 3 use cases arose. The first one was to automating inventory and artwork indexing. The second one was managing duplicates, metadata, and provenance research, including HDR. And finally, a visual exploration and interactive interfaces to show the results. So there is something that arises. This is not a revolution, but it's very interesting and very important to start an AI project, is nobody at the museum was afraid of AI, and they all agree that appropriate use of AI could be very important for the museum and help the staff to the indexation of the collection. So from that, I developed a pipeline that I call Tiamat. If some of you know the Inumaeli, you recognize the name of the sea goddess of the Sumerian and Akkadians, and the cuneiform signs for the divinity. So the pipeline is an iterative one, and we start with creating a ground truth with annotation and image distortion and augmentation, then fine-tuning a model and deploy it on new data and make correction. And the corrections serves as for the evaluation, as for creating a ground truth, and you can have it many times you need until you have a perfect or almost perfect model. And all the pipeline is based on the open source tools. So maybe it's an old-fashioned way to do it, but as you can see, the results are very good on the first step of the training model. So it's just about detecting objects on the images, and it's almost strong.
So on this slide, what you can see on the top line of the table is the different use cases that were identified by the museum staff. And for each one, on the second line, you can see what we have tried to address within this first year of the project, and on the bottom, how we're going to extend. So I'm not going to enter into detail on the perspective. I just wanted to note that we have worked on two main use cases, Tiamat for the first one, which is assigning keywords, as Marion just explained, and the other one, enhancing historical context. We discovered that there were already existing metadata, provenance metadata about this collection, and we could just process it using simple tools like Python scripts. So we didn't use AI for this task. We used much simpler and older methods, and we think it's important to emphasize that. So finally, going back to the tailor-made versus ready-to-wear issue, we have identified three scenarios. One, which you outsource completely the AI practice outside of the museum, but you create dependency risks and you lose skill inside the museum. The second one would be the opposite, so completely in-house AI practices, but this would take a long time to build the infrastructure, the expertise, the staff, and it would be costly. So we are going for an intermediate scenario, which is the institutional data strategy, and we really think that if you want to do a good good AI project in a museum, data governance is key. So we really want to work with the museum on this, having good data flows, and to have an ecosystem ready to then plug the AI projects on this ecosystem. So in conclusion, we admit that large AI models are powerful. We have also tested them in the context of this project, but when it comes to a domain-specific use case in a scientific context, you can find a balance between reusing workflows, so that's the ready-to-wear part where you can mutualize things, and having a tailor-made approach to specialize models to have a fine-grained adaptation to the specific context and to increase the relevance. So for us, Pictoria is a mutualization platform, very helpful for the ready-to-wear part, and we're also sharing these conclusions in this context. Thank you.
So, hello everyone. We want to tell you a little bit about a social topic, basically. When it comes to AI, we have a little collaboration going. That's myself, I'm Andy, and from Read Co-op, and I've been working on this with Satdeep from the Wikimedia Foundation, Adi, and also Valentina, who also worked on the presentation and on this topic and on the collaboration with the British Library. So let's take a look what we have been up to. First off, motivation. Why are we doing this and what are the ingredients? So we want to take AI to the communities that actually create all the cultural heritage or have created the cultural heritage and the documents. And for this, you need basically three ingredients. One is technology. That's what comes from Read Co-op. We're a community-owned cooperative, and we make the platform Transcribus. Wikimedia, the Wikimedia Foundation. You also need people, so all the people who create the content, who upload it, who create training data, who correct the output, etc. And it's also good to have someone who knows a bit about stewardship. So, knowing how to keep documents for a very long time, how to maintain them, how to restore them, and how to provide access to them. And the first component, as I said, that comes from Read Co-op, Transcribus, is technology. And here I wanted to make a point about the differences between general purpose and specialized AI. Take a look at this beautiful document from the Austrian Patent Office about snowplows. It has a Latin script title and an old German handwriting running text. And what a Claude model does here is it figures out the Latin script title, very nice, no transcription errors, but it can't read the old German handwriting. So what does it do? It writes a completely new text about snowplows and says, this is a fair rendering of what's on the page. I tested it a couple of months later as well with version 4 of Claude Sonnet in this case. And it wasn't able to read the title anymore either. And it said this is a text about a snow soup flask, not a snow plow. And here's a little visual aid befitting the season. So this is what you got basically. LLMs are cool and we also use them. So I'm not saying they're bad in general, but you need to know what to use them for. And with Transcribus, you can transcribe this basically without errors. Because it's adaptable. It's a specialized AI that specializes in text recognition and takes away a lot of workflow headaches. The second point is community extracted versus community-based AI. Large language models, they go out on the internet and take all the content and make a nice model that supposedly can do everything. But as we've seen, it cannot necessarily. And sometimes they even get worse on specific tasks. As you've seen, the later model was worse at reading the text. So the question is this age of pre-training these super huge models over? I don't want to answer this question. But I can say either way, domain expertise remains crucial. So the community's expertise for training the models, so for making them better, and for being able to tell if they even put out something meaningful. So you increasingly need higher expertise to tell, is this good, what the model just did? And with Transcribus, you can easily create the training data. You have, there's a bit of a layout error here. You can easily access the infrastructure because it's hosted, so you don't need to install anything. And you can easily improve the AI in that way to transcribe, for example, these beautiful palm leaf manuscripts from the island of Bali. And with this, I hand over to Satdeep.
Thank you so much, Antti. Hello, everyone. Satdeep here from the Wikimedia Foundation. You all know about Wikipedia. Today, I'm going to talk about a lesser-known sister project called Wikisource. It is a digital library of public domain and Creative Commons licensed texts, and it exists in about 80 languages. This is what a text looked like on Wikisource. You can download it in multiple formats, all for free. But behind it is the community working on transcribing it page by page, an image on one side and transcribing it there, and anyone can just go ahead and do it, add any new documents which are out of copyright and start doing it. And there are many OCR engines integrated into the system, and Transcribus is also the third one which we integrated. With that, let's come to historical documents or manuscripts specifically. We did a pilot project in Indonesia around this, inspired by the Balinese community, which primarily worked on manuscripts. They had a large collection of them. They started working on it on our platform, and we wanted to see if this is something we can scale up. Because there are many other languages in Indonesia which also work with manuscripts and have many different scripts. We want to scale up, but firstly within the different islands of Indonesia and different regions. And we did more digitization there, supported the community in going out to these local collections, someone's house somewhere, some priest in a village, and getting those resources digitized, but then also working with the community, the volunteers speaking those languages to transcribe it, and with some prizes for top contributors. And then we thought, okay, let's, after the manual transcription, can we try and create a Transcribus model on Javanese? And these are a few documents. They're from a British Library's collection, and the community had transcribed some of those pages from these manuscripts, and we tried to create a model, but we failed. It had a very high error rate. We went back to the community, asked them, can we get more ground truth? And they said, actually, we tried to create an OCR for print books in Javanese, because that doesn't exist as of now even. Can we maybe do that? And they provided us a lot of ground truth in those print books. And then we created that model. This is now public, available, and it's also now available on Wikisource. The community has been using it, and this is the only OCR engine that they can use for their language as of now. And I've been told by the community, I don't read it, but I've been told by them that this works really good, less than 10% error rate. And are we seeing this within our movement, that more and more people are working across the regions on historical documents in Malaysia or in India or Philippines? They're trying to see what they can do and how they can build this repository further. And more partners are also embracing it, like Archive Nepal, a US and Nepal-based organization. We funded them to do a project, and then a university in India, which also happens to be the South Asia hub of DBL's Endangered Archive program. And they've been working with communities, but with their expertise as well, to digitize and transcribe more documents. And just 10 days ago or so, the first transcribathon in Nepal Bhasha, or the Nevari language, happened, where they gathered 27 people for the first time to work on this language, and they transcribed 176 pages, and these volunteers were from 3 different generations, and it was a successful event. And next up, they're hoping to create a transcribus model out of this. For this, they were using a Google OCR for another language that performed with 50% accuracy. So next up, we're gonna take it forward and try and see if we can provide transcribus model support for them. With that, I'll pass it to Adi.
Thank you. So at the British Library, as a heritage organization, we obviously do digitization. We do it, we've been doing it over many years, and we do it to preserve the collection and to enable online access. And as Satdeep mentioned, we run the Endangered Archives Program, EAP, which facilitates the digitization of archives around the world that are in danger of destruction, neglect, or physical deterioration. It's been funded by Arcadia very generously, and it's digitized so far projects in almost 100 countries. Automatic text recognition naturally is a very important area of work for us, being able to provide collection items, text in machine-readable format. That means we enable search, we enable large-scale analysis. And with the advent of AI and machine learning technologies, we've been using those for both Western and non-Western collections. And we've been a Read Corp member right from the start. We've also had a really long-standing engagement with Wikimedia UK, with Wikimedia Foundation. We see this as a very powerful community-centered partnership, and it demonstrates the role of a heritage organization in supporting both openness and inclusivity. We collaborated with Wikisource on different occasions. The first one we used transcribers to transcribe early and rare Bengali books, and we collaborated with the West Bengal Wikimedians user group to run 2 Wikisource competitions. In those, volunteers proofread the automated transcriptions. As Satdeep mentioned, the Wikisource Lovers Manuscript Project, in which we shared 76 Javanese manuscripts, and 3 more were getting transcribed as part of the first Javanese Wikisource competition. And as Satdeep said, one of the aims was to create a Javanese HDR model. It was insufficient and needed more work, and this led to the idea of running a workshop tailored especially to the Javanese Wikisource community. We had a really good community of volunteers who had a lot of expertise in working with this historical Javanese manuscript, but also, were really interested to learn more about AI and how to create their own models. For this purpose, our digital curator for automatic text recognition, Valentina, she designed and delivered a 2-hour workshop, and it was a really good opportunity for us as a British Library to collaborate with the local Javanese communities, with their volunteers, so that it's basically co-creating ATR. Valentina approached the workshop design from a minimal computing perspective, considering the local context and tailoring this to the volunteers' specific needs, to their circumstances. And in our case, the circumstances were that they have a lot of local knowledge, they know how to work with Wikisource, but at the same time, we took into consideration their commitments and also the colonial context of having those collections at the library. So this can be considered as a minimal ATR solution, which is context-dependent and using technologies to co-create the ATR models and lower the barriers to access. And also, it's a really nice example of this three-way partnership between the British Library, the Read Co-op, and Wikimedia Foundation.
Thank you. And some quick final words. Yeah, we're a bit of a movement here, as you can see. And if you don't want to get exploited knowingly or unwittingly and want to join this little budding global community, then reach out to us. This is a nice little screenshot from our last preparation meeting for this talk here. So if you have an endangered archive that needs to be scanned or want to contribute to a wiki source or need some text extracted or named entities found in your material, then reach out to us and join our community. Thank you. Stay on.
Great. Thank you, everyone. That was all, each of them inspiring and great detail, too. Okay, so we have some time for questions. And the microphone, yep. Okay, we got one right here in the middle. And when you answer, just come here.
Hi there. Thank you, everyone, for your amazing presentations. I'm Sebastian Majstorovic, Open Data Consultant for Luther AI. I have a question for Satdeep. So I've been admiring Wikisource for years now, and I've never found an easy way, though, to access data in bulk. Is there a way that I just don't know about? And because obviously all of these materials, the public domain materials themselves, but also ground truths and so on, are extremely valuable as open source research data sets. Thank you.
Yeah, we can definitely talk later. I'm not a technical person, but I do know we have an API, and so there should be ways. We don't have the best documentation, I have to agree. But yeah, we can definitely figure it out. Thank you.
Are there any other questions from the room? Over here?
This is a half-finished thought, so bear with me. I was kind of reflecting around all the presentations throughout the day and how everyone has treated communities and the people that we work with. I really appreciated, Satdeep and Adi, that you actually included pictures of the people that you work with. You referred to the volunteers, and it was really great to see that. In most of other presentations, we kind of talked about people in terms of like user testing. So we have the product and then we evaluate it, right? So I'm wondering if you think kind of now with us, many organizations moving towards these LLMs and chatbots, etc., do you feel like we're not entering this dangerous trend where we're only using our communities as basically for user testing rather than actually the owners, the people who are represented in the collections, and the knowledge experts who should be consulted at the first step before we even consider building solutions? So this is just a reflection and question perhaps for everyone who wants to jump in. Thank you.
I agree. And as you say, this is the reason why we thought this was quite a special case, because we really brought the community to the center. So I think maybe in this case, the AI kind of takes a side supporting role, but it's really about the people, and it's really about their collection. It's not doesn't belong to anyone else. It's really about them. So I think it's really important that we see more and more of these type of collaborations, which don't forget or don't kind of minimize the human side of it, because then we really lose why are we doing it in the first place. You know, this is why it's important. These are the people that we work for, really. You know, we as a library, we exist for the users, for our readers. So if we now take AI and you know, we do anything without the people, then we kind of lose one of the main values that kind of underscore our work. So I agree.
Thank you. More questions?
We've got one more online.
Okay, let's try that again.
Separate question, but we can come back to it.
Yeah.
So for the BL Transcribus Wikisource team, question regarding the Javanese, this is from Sinai Ruzinek. One of the great challenges in platforms like Transcribus and eScriptorium is the preliminary segmentation. The Javanese material seems especially challenging. Did you have a specialized team working on the segmentation before letting the transcribers work on it?
No, in this case, we're using the standard models that are readily available within Transcribus, but we're also working on a new model generation that's segmentation-free and produces the coordinates in post-processing so that you have an easier time still correcting the material, because coordinates are still handy if you want to click on a line in the text viewer and then see where this is on the page. But it's a segmentation-free approach that will also come to Transcribus, and that may also increase the quality of models for languages such as Javanese.
I can also add something. So in that particular workshop, one thing that we realized, actually speaking with the Javanese volunteers, was that probably the best approach in that particular case, before the arrival of the new models, was like creating first a segmentation model and then move to a language model. Because when we started segmenting, we realized there was like it couldn't work. So they didn't realize, because they didn't know all the various options on Transcribus. At the same time, I didn't realize how complex it was, the polygonal division and the different lines, and how it was supposed to be read by the community. So that's what made the workshop so interesting from both sides, and why we wanted to do this with a community.
Yeah. And I got the signal we have 2 questions from online, so let's go there.
Yeah, so 2 from Summer for the Harvard team. The first one I've definitely thought about as well. How did your team measure the amount of relevant materials that were excluded from return search results? Was that investigated? And then the second one was, will there be any context around the thumbs up or thumbs down feature? For example, if a user gives a thumbs down to an object that is relevant, but they just either don't realize or don't like the relevancy or result, how will those kind of complexities be investigated?
So for the first question, we have user feedback through the survey. So if there's anything missing, but I'm wondering if your question is more about things that were excluded maybe because of the guardrails, and that might be an Angela question. For the second part, regarding the thumbs up, thumbs down, if you choose thumbs down, there will be a pop-up window that comes up, and you can pick from some options like the information is wrong, this is irrelevant, and you can also give written in feedback. So, if Angela, you want to take the first part of that question.
Yeah, for the guardrails are, so I can say the guardrails, if they are kind of invoked by the output for the summary, the user will still get the search results. It will just not generate a summary. It'll say a summary could not be generated for this material. So I think that we're handling that right now.
Yeah, I think one other thing I want to say about kind of material that's not found in a result, I think there's a couple different dimensions. There's one, there's the guardrails, there's 2, the system not doing the right thing, and there's content in the collection that it doesn't find. But I think 3, and most importantly, maybe something we didn't kind of highlight enough, we've started pretty small. Right, I mean, we, like many of you, have a really big collection, and we started with 11,000 finding aids. So there's a lot that's not going to come up yet. Amy and her team have a pretty robust kind of process for evaluating gaps and mistakes, et cetera. And I think as we expand the scope of what's in the system, we'll be able to kind of zoom in a little bit more on what's not finding that it should.
Okay, well, that is our time. Let's thank our presenters again, and then we're on to the lightning round.